Macular degeneration is a leading cause of vision loss, with 15% of Americans being at risk or already affected. Scientific evidence proves that by using mesozeaxanthin, lutein, and zeaxanthin together replenishes the macular pigment and promotes healthier vision. This formula comes in only one product, MacuHealth.
Hello and welcome to the Open Your Eyes podcast. I'm Dr. Kerry Gilb, the host of the documentary Open Your Eyes. Please visit the film's website at openyoureyes2020.com, featuring interviews with more than 50 optometrists from around the country, sharing information on eye care and eye disease. If you're new here and you like our interviews, press like, subscribe, share, and hit the bell to get notifications of great new interviews. Also, please leave comments. Macular degeneration, or AMD, is the leading cause of blindness in people over the age of 50. The WHO estimates about 340 people go blind in both eyes each day from this devastating disease. Today's guest, Professor John Nolan, PhD, has dedicated his life to preventing blindness from macular degeneration, as well as how one can optimize visual function through nutrition. Dr. Nolan is a Fulbright Scholar and currently holds a chair for human nutrition research at the School of Health Science, Waterford Institute of Technology, Ireland. Dr. Nolan is the founder of the Nutrition Research Center, Ireland, as well as the director. His Macular Pigment Research Group studies the role of nutrition for vision, cognitive function, and prevention of age-related disease. Professor Nolan has published 106 peer-reviewed scientific papers. He can be found at www.profjohnnolan.com. That's www.profjohnnolan.com. Welcome, Professor Nolan.
Very nice to join you today.
You know, John, I followed your work for so many years, and you've made such a great impact on the vision community. I routinely use the research you do in helping my patients. And I just want to thank you from the whole vision community, from all the doctors out there, for the hard work that you do and all the research that you do.
Kerry, thanks very much. I appreciate your kind words and your comments. I think, however, really the celebration here relates to the work that optometry is doing in recent years in this space, because we can do science all day long. We can publish papers, and this is our currency of achievement, I suppose, publications and research grants and so on. And, you know, over the last number of years, we've been very fortunate to get access to technologies that allow us to do science at a, you know, maybe a quicker pace or at a more sensitive level to answer research questions that maybe before we couldn't. But because of optometry, and particularly in North America, I must say, you've absolutely led the way in implementing and translating some of it, which is difficult science, to help patients. And I think clarity around what that looks like for the future is what's going to be key if we are to impact positively on that.
One of the statistics that gets floated around is that it takes 17 years when research is done in the lab to be transferred to the physician's office. It seems like that 17 years is starting to narrow a little bit because we have the internet and we're able to see studies. But what do you think? How can we shrink that down to get the great research you do into the doctor's offices a little bit quicker?
Yeah, you're right. I mean, one of the great achievements of current times is relating to, you know, how we can communicate. Okay, so now it doesn't just have to go through a peer-reviewed process where it gets published and sits in a journal where eventually people get to see it. Now we have the opportunity, for example, when we look at COPE education and when we look at, you know, all the many seminars that are ongoing, the optometrist gets firsthand and extremely quickly the latest data. And I think from a research perspective, we also see that, you know, the confidence and the emphasis now being put on the researchers to disseminate and educate to optometry. And by doing this, patients benefit much, much quicker. And that's the way it should be. Because if you think of it, the good research and the research that's independently funded. So for example, the work that we did as part of our European CREST trials. So this was research that was funded by the government, if you like. And that research fund, part of that is that we are in a position to use the research to help people that can benefit. So societal gain, societal impact is fundamentally important to what we do for the future.
So I want to start with, is there a difference between the brain and the eye? And is it one? Is it the same? If you could explain that from someone who does research in this area.
So yeah, absolutely. I mean, the retina is part of the brain. It's the seeing part of the brain. It's the part of our central nervous system. And, you know, of course, when I began my research now 2 decades, over 20 years ago, we began our project on macular degeneration and how nutrition was related. What we've seen over the last number of years is that by measurements we do in the retina, we can learn about what's happening in the brain. So for example, when we measure macular pigments correctly in our research facility, we're getting a measure of the concentration of the macular carotenoids, the macular nutrients that are there. What we've seen, and this was a great work done out of Tufts University, Professor Liz Johnson's laboratory, they were able to actually show us that the amount of these pigments in the living eye correlates to the same nutrients working and stored in the human brain. So now optometry and eye care and these measurements is uniquely placed to function as a biomarker of brain nutrition. So add into that we know that these nutrients are good. Therefore, if we can measure them, see who's high, see who's low, and make lifestyle modifications and maybe supplementation to enhance retinal health, we now also know that this is really good for cognitive health, cognitive functions. And our recent work, Kerry, as you'll know, has been very impactful in terms of, you know, even helping people with dementia and Alzheimer's disease. Not just from the cognitive piece. I think when we look at vision and when we look at what our work has been able to achieve, we need to understand what we're actually measuring. It's not as crude as just saying visual acuity or even contrast sensitivity. It's what those measures of vision or cognition mean for the quality of our life. And that's very individual to the individual, if you like. So for example, if we take a young, healthy, high performance sports athlete or someone that's in the military or someone that uses high performance visual related or cognitive related performances, subtle improvements in visual functions and cognitive functions for that population is extremely important. But go to the other extreme. And when we look at people, and we've been, you know, had the great pleasure of working in the area of dementia and Alzheimer's disease for the last 6-7 years now. And when you look at what it means to patients and to their carers, their loved ones, the people that have the time with these individuals, if you can do anything important to help with their quality of life, well, this makes it all worthwhile. And I really, really want to, you know, empower optometry to think in this way, that the work that we can do with lifestyle, nutrition, and optimizing those extends way beyond that of a basic measure of visual function. It's the impact on the quality of life and the performance. We're creating new standards for what's acceptable for vision.
Let's talk about cognitive function. Now, how can we use the eye as a biomarker toward cognitive function?
So, well, there's a couple of things. I mean, one of the key measures that we see, you know, in some of the published studies, Professor Stringham, for example, has done a lot of work with CFFs, which we measure in the retina, okay? And this is an absolutely brilliant indicator of cognitive function. And it correlates beyond that of just that measure of retinal processing speed, or this links into attention, memory, reaction time. What I would say is that when we look at kind of these age-related diseases, such as age-related macular degeneration and Alzheimer's disease, by enhancing our sensitivities of measurement, by stepping out of the measurement of acuity, for example, and moving into other measures of visual performance, what we're seeing is that we're learning much more about vision and visual performance for people before diseases even affect them. So, for example, let's take cataract as an example. Typically, a patient will come into the eye doctor and you'll see that their acuities are fine, right? And you may say, look, I'm going to let it for a year or 2 years. Now, in that same patient, if you were to measure their contrast sensitivities, you'd start to see the contrast sensitivity measures decreasing to, or being suboptimal, if you like. And so what I'm saying here is that the other measures of vision can be indicators of, you know, quality of life, performance, or even retinal disease years before those diseases even present themselves. And this, of course, we must look at diseases like macular degeneration and Alzheimer's disease in the same family, if you like. When you look at the risk factors for these conditions, they're almost identical, to be perfectly honest. And of course, a big player in that is our genetics. But our genetics is not something we can change in the current time. It is something that we change in the future, of course. So what do I mean by that? By good lifestyle today, we can change the genetics of the future for our offspring, for example, or this whole concept of epigenetics. But the point being, in today's world, and for the patient that sits in your chair today, you must look at what's modifiable for them today. And there's very little actually that you can change. I mean, if we look back to my own PhD, you know, which is 20 years old now, that research question was, well, what is it about age-related macular degeneration and this nutritional pigment, macular pigment, which I've been studying all my life? And what we did was we wanted to look at where there are commonalities between the risk factors of the disease macular degeneration and determinants of macular pigment. So what do I mean by that? So when you look at a patient with age-related macular degeneration, we know that the established risk factors are their age. There's nothing you can change about that. Their genetics, there's nothing you can change about that. Cigarette smoking is a big one. We all know this. We have to advise our patients not to smoke cigarettes. But next in line is really nutritional optimization. And the point being, when you look at this risk factor as an established risk factor, subtle modifications there can have a major impact on the time at which the patient is going to be hit by this age-related eye disease. So essentially you can push out the age. And remarkably, in my PhD from all those years ago, what we showed very clearly was that these risk factors, age, family history, cigarette smoking, and nutrition, were the exact major predictors of the pigment. So in other words, young, healthy people like you and me, okay, without retinal diseases, when we characterize ourselves in terms of those risk factors, those who smoke cigarettes, those who had the family history of the condition, for example, and typically led bad lifestyles, their macular pigment levels were very, very suboptimal. And this is really important because it's in tune with the entire hypothesis that we speak about. It's what we do throughout our lifetime that's going to impact on whether we're going to get the disease or not. And that's something that I really like to talk to optometrists about, because what we need to do is move away from eye care and medicine that waits until the problem presents before we do something to optimize or modify or reduce our risk of that. Now, I know that's challenging, particularly in ophthalmology where time, and in optometry where time is a problem. People simply don't have it. But if we make time for this, optometry can absolutely lead the way to make changes during a person's life that gives them better vision today. We're going to create a better world of visual, a new standard of vision. But the really good news thereafter is that we're going to reduce the risk of these age-related conditions such as macular degeneration and Alzheimer's disease. You know, remember, if we all live long enough, we will all develop age-related macular degeneration. So age is great. It's a great success of modern time, aging population, but it's also the biggest challenge we have. And really, you know, eye care is fundamentally key to how we can positively impact on that. Hence why I'm really pleased to participate on events like this or educational seminars across America, because I do think that North America is leading the way. North America optometry, that you have your champions there that are really setting the example, because the industry is changing greatly, and people see this, and patients see this, by the way. You know, I don't look at optometrists anymore the way I used to, which was, you know, people that will give you spectacles if you needed spectacles because you have a refraction problem. No, that's not what this is about. Optometry equals the first line of eye care. And I know you know this yourself from your great work with Open Your Eyes and what's coming with your great documentary. It's the indicator and the work that we can do early on to really help our patients in real time.
Now, if we look at the macula is only about 4% of the retina. But how much of the visual function is it responsible for?
Yeah, what a great question. So yeah, it's about 4% of the entire retina, but you know, it's responsible for over 90% of our visual functions. And all of our central vision, all of our color vision is mediated from the macula. And this is what got me extremely interested in the biochemistry of the macula, if you like, because I'm not a vision scientist. I'm actually a trained biochemist. That's what my primary degree is. I did my PhD in vision related science with macular degeneration and so on. So absolutely. I mean, I was amazed, right? I remember doing my Fulbright scholarship in Augusta, Georgia, Medical College of Georgia, and I'm speaking to some of the top vitreoretinal surgeons, ophthalmologists there. And speaking to them about, you know, the macula and then I would say to them, well, what do you think about, you know, the carotenoids and the macula lutea, the yellow spot there? And it's amazing because it's not part of their training. And even though they look at it every day, it's not something that they actually really comprehended to be important. So then the value of what we're talking about today is that, you know, the world leaders in this space, and there's not too many of them, to be honest, in this area. It was led by, you know, the work Bone and Landrum, Max Snodderly, you know, Randy Hammond, you know, Jim Stringham, Liz Johnson, Paul Bernstein, myself. These are the scientists, essentially, that have had the real great value of being able to dedicate our career to this. So by bringing, the point I'd like to make is, by bringing in, you know, a multidisciplinary research approach to understanding the macula, beyond that of ophthalmology and optometry and vision, was fundamentally key to the discoveries around macular pigment and why and how we can enhance this pigment for patients today. Because, you know, we can measure vision, that's fine, and we're getting better at that every day, thankfully. But equally, the carotenoid scientists, the people like me, had to work really hard to understand how we can actually measure the pigments. And I don't just mean measure the pigments in the eye. This starts when we're looking at food, when we're looking at supplements, when we're looking at formulations that are available. The science begins right back there, right at the beginning of the equation. Because one problem with science and essentially implementation of science is if you make too many assumptions, you'll get caught out. And I think this happens too much. We make an assumption that everything is the same. We make an assumption that, you know, if lutein is in a supplement, for example, it's been tested or it's going to do the same thing. The point is it's not. These carotenoids are highly sophisticated in terms of how they need to be formulated, how they need to be managed, how they need to be stabilized, and what that means for the success of a research study, or even thankfully now in the case of clinical implementation, which is what optometry does. So we've been able to map and connect the knowledge around the macula and the brilliance of the macula to the brilliance of understanding these carotenoid molecules that are so beautifully concentrated at the macula.
You spoke before about carotenoids and brain function, and we're going to get into that. We're going to get into the studies of it. But let's build on it for people who don't understand about what carotenoids are, what macular pigment is. Let's start with what are carotenoids, how important they are, where do we get them from?
Yeah, thank you. So carotenoids are, put simply, they're plant-based pigments. And, you know, they're sometimes presented as vitamins or minerals. They're not. They're actually just plant-based pigments. They're lipid-like molecules that live in the plants that we have in nature. We know there's over 700 carotenoids in nature. And the thing I like to say about carotenoids are, the first thing they do that's nice is they give the world its beautiful color. So when you look at flowers, you look at vegetables, you look at birds' feathers, you look at fish skin, the colors that you see in all these beautiful things are because of the carotenoids. Now, where it becomes interesting in terms of human biology is that from the 700 carotenoids in nature, we have about 50 of them, which we consume in a typical Western diet. What's really interesting after that is from the 50 that we might consume from eating fruits and vegetables. And remember, if you don't eat fruits and vegetables, you have none of these carotenoid pigments in our systems. But if you do eat fruits and vegetables, plant-based diets, what you can have is up to 20 carotenoids circulating in what I like to call your taxi system, your blood system, okay? it even gets more interesting because macula, which we've just been speaking about, remarkably, we have binding proteins there that select, accumulate, and concentrate only 3 of those 700 carotenoids. And they are lutein, which most people may have heard of as being important for eye health, zeaxanthin, and what I believe to be crucially important is mesozeaxanthin. So collectively, these carotenoids they basically are concentrated within that 4% of the macula. Typically, they'll form what we call a mountain-like profile, like a mountain. And at the center of that mountain, you have mesozeaxanthin and zeaxanthin as you move further out, and lutein as you move further out again. Based on the anatomy studies, so studies where people have actually taken retinas and extracted out the carotenoids and tried to understand where they're located and how much of them are there, the recent data shows us that we have equal concentrations of lutein, zeaxanthin, and mesozeaxanthin. So that's 1:1:1. Now that's really important actually, because in a typical diet, you're not consuming 1:1:1 equal amounts. You're consuming much more lutein than zeaxanthin and much more lutein than mesozeaxanthin, zeaxanthin being the lowest in terms of the concentration found in the diet. Therefore, why is it in the macula?
What foods contain lutein? What foods contain zeaxanthin? And what few foods, but there are some, contain mesozeaxanthin?
Absolutely. And before I answer that, I'd like to say that the scientists that measure carotenoids in food, I can tell you that the work I can do in that today is different than what it was 6 months ago, because the sensitivities on how we can extract and quantify the carotenoids gets better and better. But to answer your question, any of the leafy greens, spinach, kale, bell peppers. In Ireland, for example, the biggest intake of lutein comes from peas, believe it or not. What's a beautiful source of carotenoids are, of course, egg yolk. The colors that you see in the egg yolk is due to the carotenoids. You have zeaxanthin and lutein. Now, there's a lot of eggs in society as well with mesozeaxanthin, because when the hens now, particularly from Mexico, the feeds that they get include all of the carotenoids. So eggs, for example, in Mexico have high amounts of mesozeaxanthin. The other foods where you get mesozeaxanthin, albeit in small amounts, as you say, you'll see fish skin, typically seafood. We've also seen mesozeaxanthin in blood pre-supplementation. So that's really interesting, because what that tells us is that there may actually be foods containing mesozeaxanthin that we haven't just yet been able to identify as being a source. So what's understood is that we actually can convert the lutein into mesozeaxanthin, but we should talk about that, because
we're going to talk about
an
that
interesting
in a minute. But I want to ask you about the skin, the fish skin. Very popular in sushi restaurants in the United States is salmon skin rolls. Does that contain mesozeaxanthin?
Absolutely. Yeah, work from a brilliant scientist at our laboratory showed that trout skin, salmon skin contain mesozeaxanthin in much higher concentrations than, for example, lutein or zeaxanthin. There is one crucial thing here I'd like to say, and let's clean up one misconception. The conception that is, if you eat healthy, you're going to get loads of lutein. And you're going to get more lutein than you are zeaxanthin or mesozeaxanthin. That's a fact. But you're not getting enough. So even your healthiest patient is probably 15 to 20 times away from having the amount of these carotenoids that he or she needs to give them the optimal amounts in their biological system and thereafter in their eye. The point I'm making here is that unlike lots of vitamins and minerals, and I know you're big into your nutrition, Carrie, in terms of your understanding of it and the benefits of good supplementation. I'm not an expert in loads of areas of supplementation, but what I can tell you is, and if we take the ARIDS formula, for example, zinc, vitamin C, and all the other co-antioxidants that are in those interventions. When we look at carotenoids, there's a big difference, because we're just not able to get enough from normal foods. Whereas with vitamin C, for example, you can get loads of vitamin C from eating healthy and good food. Certainly you can get loads of zinc from food. Omegas is another example. From good food, you can get it. And that's where I think one of the big discoveries is. I came into this exercise really anti-supplementation. I wanted to do this with nutrition. I really did. But I found out very quickly that if I wanted to have an impact for the patient during their lifetime, there's a major role for safe and targeted supplementation here. And this is why I think supplementation with the carotenoids is uniquely important, because we're fixing a deficiency, we're fixing a problem that normal food cannot provide.
Vision Edge gives you less eye strain and reduced damage caused by blue light. We like to call Vision Edge sunscreen for the eye. It all starts with your highest level of visual performance, only achievable through scientifically proven Vision Edge.
Thank you for tuning in to the Open Your Eyes podcast. If you like the video you're watching, please hit the like button. Also, hit subscribe for weekly new episodes of the podcast, along with pod winks and bonus content. All right, let's get back to the show.
You know, many physicians in the United States for years told patients that supplements were just expensive urine. But the American population isn't buying it because 86% of Americans take a supplement. And it's in the US, it's over a $30 billion industry. So wow. The American people realize that supplements are important. And it's our job to help them to determine which are the best supplements that we should take. And we're going to do that as we go through the interview. But I do want to ask you, as you eat foods that get transferred to the macula, what's the transport mechanism? Is it HDL? Is it LDL? Which is it?
Well, there's a lot of work to happen before our HDL or our LDL get involved, okay? And the reason being, so you mentioned there in your question about, you know, expensive urine. And this is typically, of course, related to the water-soluble vitamins, like vitamin C is an example of that. We all take 1,000 milligrams of vitamin C. You'll see it later in the day, right? Because you don't need all of that, basically. You get saturated. But the carotenoids are fat-soluble. So you won't see those in urine, for example. So they're stored in your fat systems. Now, the first exercise and the first challenge with carotenoids, Kerry, is when you consume them, is how bioavailable they are, how ready they are for our binding proteins to capture them once they go on their journey. What is their journey? Their journey is they have to go in to your stomach. And if they're purified and available, what will happen is they'll typically they'll clump together. They form these kind of crystals and they'll join together. And the first job is that they have to be put into what we call micelles, which are basically, not to get too technical, but they're special transporters. They're like little packages that take these fat-soluble nutrients. They don't like the stomach, remember, because the stomach is a water-based system. So that's why we say consume your carotenoid supplements with a meal, because you want to have a certain amount of fats in your system. Now, the body is working to do this for us, of course. We produce these micelles, and these micelles essentially can latch on, join to the intestine, where they can go through the wall of the intestine into our lymph system, our blood system, where they get transported to the binding proteins at the target tissues, such as the eye or the brain. So that sounds kind of complicated, but basically what you need to remember is they're fat soluble, so they need to be packaged. They have to be transported in a particular way. And our newest science, which we'll probably come to later, has allowed us to identify a unique way to do that to greatly enhance the bioavailability of these carotenoids.
And that was the COAST study that you published.
That's right. The most recent publication of last year, Dr. Marina Green, her own dissertation, PhD, that was a major work that she did with us on that.
So do we know if it's the HDL or the LDL after this is done that transports it to the macula?
So we believe that the HDL facilitates the carotenoids. There's great work by Dr. Earl Harrison that suggests that. There's some conflicting data on that, to be honest. The clearest message I see is that a good diet with good fats, good HDL is a better transporter for these carotenoids on their way to the target tissue. Of course, that's going to help on the process.
Because I saw that research and I always found that confusing, because HDL brings lipids back to the liver, where the LDL brings lipids as a transporter that brings lipids and different nutrients to the tissues. So I always found that always
counterintuitive to a degree. Yeah, I would agree that it's not absolutely clear cut. There are some papers that suggest no difference in terms of the HDL or the LDL and in their impact. Actually, even work from my center, Dr. Edward Lowen, maybe 15 years ago, did some work there. But I would say that the newest science is supportive to the concept that HDL seems to be playing a key role in transportation of this.
So let's talk about the functions of carotenoids, especially the anti-inflammatory and the antioxidant functions. Now, explain the difference between antioxidant, anti-inflammatory. Do they run together? Do they run separately? Are they circular?
Okay, great questions. Okay, so the basic concepts here for the macular pigments, the macular carotenoids. Firstly, before we go to antioxidant, anti-inflammatory, let's just excite optometry a little bit by speaking about optics. Because the first thing I'd like to say is that this industry spends so much time worrying about the front of the eye, and so it should. But you know, in terms of the results of vision, the retina is giving us about, I think it's working at about 80%, 85% of determining whether we have our vision and what's that like or how good or bad it is. So the reason why I want optometry to be excited about this is because we're talking about internal optics. We're talking about customized optics, firstly. Why is that? These pigments are yellow. So they filter short wavelength light at 460 nanometers. So this is really important because, you know, when cataract surgery happens, for example, what's happening as a standard is a cataract surgeon, he or she is putting in a UV filter. And that's going to filter the majority of the UV light from getting to the back of the eye. But the retina must contend with the visible light spectrum, the colors of the rainbow, if you like. Now, the short wavelength, high energy piece of the visible light spectrum is blue light. And blue light is a major problem for vision, even in a healthy patient. Couple of reasons why. Number one, blue light itself is a photo-oxidative stressor. So that causes oxidative stress. So let's come back to oxidative stress in a second. The other thing blue light is a problem is that we have no blue photoreceptor cones at our macula. So in other words, you have all this particular wavelength of light that's hitting the back of the eye, and the eye can't process it, to put it simply. This causes veiling luminance. This causes light scatter inside the eye. This causes suboptimal visual experience for your patient. Scale that up to a disease like macular degeneration, and this is a problem that even gets worse. Now, I'll come back to the second piece, the photo-oxidative stress, okay? So if you can filter the blue light with these macular carotenoids, and you can filter a lot of blue light if you optimize, enrich these pigments the way we've shown in our studies, you not only reduce the amount of photo-oxidative stress, you make the retina healthier today. So basically you make the retina work better. What's the retina doing? It's capturing light. There's this electrical signal that must be sent to the brain, the signal to noise ratio. A retina that works better is a retina that gives your patient better vision today. And this is really interesting because, you know, I see and we see improvements in visual function, Kerry, even before we see optical improvements in the pigment. So what I'm saying is, even before we can measure macular pigment to get increased, we can see visual function benefits. And Professor Stringham and I believe that this is absolutely due to the fact that we're actually making the retina healthier very, very quickly with this type of intervention. So the oxidative stress piece is really important, of course. Why? Well, we have this normal balance of oxidative stress. Let's think of oxidative stress as the cost of doing business with life, okay? We all need to metabolize, use oxygen. The cells use oxygen to survive. The cost of that is a byproduct, which is called free radical damage. And free radical damage is simply a result of oxygen metabolism, where these molecules, which are unhappy molecules, they're unstable, they're missing electrons. And what do? They love the retina, right? Because the photoreceptors at the retina are the ideal substrate for these to be attacked. So they'll basically want to attack the stable cells in the retina. And the other key point in terms of the oxidative stress piece is that we metabolize more oxygen at the retina than any other tissue in the body, the retina and the brain, in fact. So the problem of oxidative stress equals this free radical insult, if you like, this attack by these unhappy molecules. And put simply, Kerry, if we don't have enough antioxidant mechanisms to protect against that, the bad result is you're going to kill the cells of vision. And if you kill the cells of vision, you're going to develop these drusen, the early stages of macular degeneration, of course, and eventually you'll get this whole atrophy at the retina, which results in central vision loss and this horrible disease called macular degeneration. So the macular pigments are ideally concentrated and have the ideal optical and antioxidant properties to really help the retina. But I want the doctors that are listening to this, and even the patients or whoever's listening, to think about this as it's not something we should do when we have the problem. It's something that we need to do before we have the problem. And if we do that, not only will we protect against the problem happening in the first place, we're going to make the retina work better. We're going to give our patients a better vision. And isn't that exactly what optometry should and must do in today's world? Now, the last piece of this question relates to inflammation. There's two things that are interesting here. Of course, you potentially have this systemic anti-inflammatory effect. So there's circulating in our systems and working in that regard. But also we do know that, you know, with diseases like macular degeneration and Alzheimer's, inflammation is the big ticket item. This is what we see, you know, these tissues are inflamed and then the body tries to fix itself. That's what really happens with this advanced wet macular degeneration. There's so much sickness in the retina. It tries to fix itself. And what does it do? It be inflammation. You know, so we produce these unwanted blood vessels, if you like, right at the area of vision, right at the macula, which we spoke about, giving us all our vision. And if we have these, it's the body trying to fix itself, causing the problem. No different to what we see in current times with COVID, for example. What's killing people with COVID is not the virus, it's the immune response to the virus. It's the body trying to fix itself. So, you know, the advanced treatments around inflammation, of course, for any listeners that may know people that are being treated for macular degeneration, this is only, as you will know, for the very advanced stage of the condition. We call this anti-VEGF therapy, and simply these are injections that stop the growth of those blood vessels. And that has a positive impact in terms of management of the eye disease, macular degeneration. But I'd really like to say here that, you know, you don't get inflammation unless you have an insult. So what's the comparison to this? You know, I see my 2-year-old yesterday playing out on the swings, and she falls, of course, and she bumps her knee on the floor. So she has inflammation on her knee. And the insult is the impact, the hitting the floor, if you like. The result of that now is the swelling and the blood vessels and so on. The point I want to make here is if you can stop the fall, if you can stop the insult, you can stop the inflammation occurring in the first place. And the trick to this, in my view, is reducing the oxidative stress. So in other words, you do not get inflammation without an insult. And in the case of the eye, the insult, the negative impact is the oxidative stress. So antioxidants are fundamentally key to this story, whether we're talking about the optics piece, the filtering the light, the antioxidation. So they're very good antioxidants. Think of them as sunscreen inside the eye. And they have these anti-inflammatory mechanisms as well. I do think more work needs to be done in their anti-inflammatory capacities, particularly in what we're doing with the brain. You know, there's a lot of very interesting work happening at the moment in that space. And it's certainly something that my laboratory is focused on for the future in terms of the work we can do.
Paul Bernstein did some work that the best antioxidants for the macula are lutein, mesozeaxanthin, and zeaxanthin. If you could talk about some of the research that he's done to use those 3 triple carotenoids as protection against macular degeneration.
Yeah, Paul is a great exception, isn't he? Because Paul he's an ophthalmologist, of course, but he's also a brilliant scientist. And to get that both of those is fundamentally brilliant. So he has proper laboratories to do this work. And you're right. So the paper you're referring to, the peer-reviewed paper, is paper by Lee et al., I think, in 2011. And this was work where, as you say, these carotenoids, these compounds are really important to the macula because they have antioxidant properties. So they can reduce the free radical damage at the macula, exactly what we want them to do. So they did a very nice experiment where they actually measured the antioxidant potency, the antioxidant potential of each of these carotenoids. And what they found very clearly in this experiment was that lutein was a good antioxidant, zeaxanthin was a better antioxidant, but mesozeaxanthin was the strongest of the three antioxidants. But the story doesn't stop there. The really interesting finding from that work was when you looked at the three carotenoids combined at the same total concentration, the antioxidant potency potential of the combination of the carotenoids was significantly better than even mesozeaxanthin or lutein. So what we, in biochemistry, we call this a synergistic effect. They help each other do the job they're supposed to do. So I call these carotenoids brothers and sisters. They're very similar in their structure, basically speaking. Okay, that's why I laugh when I hear suggestions that, you know, maybe one carotenoid is more important than the other, or one carotenoid is bad and the others are good. That's absolute nonsense. They're very similar in structure. They have subtle differences in their end chain of the molecule. Those differences achieve two things. One, to your question on Paul Bernstein's work, the antioxidant capacity of the three carotenoids, and particularly mesozeaxanthin, is far superior, but also from the filtration piece, because of the structure of these compounds, how they locate themselves at the macula, and thereafter how they filter light is optimized when you have the three carotenoids. And this is why we have evolved as humans to have three carotenoids, not two carotenoids, not one, but three. And they are strategically placed, they are uniquely placed, and there's a reason why we have the three. This is not complicated. We have a jigsaw here that's made up of three parts. And the recent science from our laboratory, and from, you make reference rightly to Paul's work as well, the recent science shows us how we can validate and demonstrate the importance of having and using safely those three carotenoids.
Now, Joanna Seddon, she was one of the original, Dr. Joanna Seddon, the original researchers on macular degeneration and cataracts. And she showed that if people ate quite a bit of spinach, the ones that ate the most compared to the least, decreased their progression of macular degeneration by about 43%. But amazing, the spinach that we ate in 1950 is not the spinach we're eating in 2021. Can you talk about how our food has changed, and we don't have the same amount of nutrients in our food today that we had 50, 70 years ago?
Yeah, I mean, absolutely great question. And you know, Joanna Seddon's work has been so fundamentally important to what our research field has been able to understand and develop beyond. What I will say to you on that, we have done some work on this ourselves actually. But firstly, let's look at it at a generic level, global nutrition, if you like. So the situation we have is that we have lots more food around, of course. We have lots more people on the earth. There's a requirement for more food. But what does farming do? Farming basically picks the best crop, it overproduces it, it tries to grow it at a quicker pace to have more of it, and the economy comes into it then. And what does good farming in theory, makes it easy for a crop to grow. You don't want to, and they use various ways to do that. Some of them are natural, some of them are not so natural. Regardless, the net result is that we're producing plants today that absolutely do not have the same nutritional scores than they did, as you say, 50 years ago. I think that one example is to spinach, actually. I think 63 years ago to today, you would have to consume, to get the same nutritional value, 43 more portions of spinach to get that same value. Now, when we look at this from carotenoids, it becomes even more interesting, because what you should know from this is that carotenoids, these nutrients which we're interested for our eye health and brain health, are not in the plants to help the humans. They're in the plants for the benefit of the plants. And the point being here is that plants accumulate carotenoids so that they can grow in difficult or unusual environments. So in summary, when you make it easier for a plant to grow, essentially what you're doing is you're turning off the need to produce carotenoids in that plant. So our spinach or our kale or our bell peppers today do not have the same carotenoid scores as what they would have had 50 or 100 years ago, certainly. And this is one of the reasons why we just cannot do enough with good nutrition. Now, I don't want your listeners for a second to think that John Nolan is saying good nutrition is a waste of time. It's not. It's our pillar to begin with. It's exactly what we should do. It's exactly what we should recommend. But specific to carotenoids, Kerry, there's a role for targeted and safe supplementation of the 3 carotenoids. The other challenge, to kind of finish out on this good question that you asked, is that when you look at the impact of CO2, we've shown ourselves that increased CO2 levels is negatively affecting carotenoid content in plants. There's a massive decline, a devolution, if you like, of carotenoid amounts in plants because of the environment as well. So there's a couple of challenges here, but the learning from it is that, yes, we should do good with good nutrition and natural foods are great. But if you really want to change something and you want to optimize your biological systems, and remember, it's not just the eye or the brain, it's the skin, it's the liver. We have to sort out all of our fats. That's why it takes a while in an interventional study to change tissue concentrations of these nutrients. There's a bit of work to do with that, and supplementation is absolutely something that needs to form part of optometry. And what I would say to optometrists is, please don't be casual about this. You know, don't think it's not your responsibility to understand this or to implement this, because if optometry doesn't do this, Kerry, it's not going to happen. And the science that Paul Bernstein, Liz Johnson, John Nolan, Jim Stringham, whoever performs, it's not valuable if it doesn't get implemented and used by your industry.
Well, I think the good news is that it's becoming more and more mainstream. And more optometrists are recommending the right supplements, the proper supplements. Like I like MacuHealth. I mean, it's also a sponsor, but I like MacuHealth. That's what I take myself. That's what my wife takes. That's the one that I like. That's the brand that I like. But I want to get back to something that you were just talking about. So number one, as we get older with age, we don't absorb very well anymore the nutrients. And a lot of people are on medication. And a lot of times medication will interfere with absorption of different foods, making it important to supplement. And then if you look at the Western world, what percentage of the Western world actually has carotenoids on a daily basis?
It's very small. And you're right to talk about absorption. You're also right to talk about quantity. Again, I'll go to an extreme on this, Kerry. You know, in 2016, we did our first experiment with Alzheimer's disease, okay? And when we measured macular pigment, it took us 2 years to get ethical approval to work with this population. And we discovered that, remarkably, they almost had no macular carotenoids. So the question was, did they have no macular carotenoids because they weren't able to accumulate them, or there was something genetically that predisposed them to this deficiency? And the reality was, just as you suggest, it was down to nutrition, not eating the right foods, not eating any foods in some cases. And the result of that was biological systems and tissues that need these nutrients totally devoid of them. And that was a big problem.
People want to know, other doctors have asked me to ask you this question, knowing that I was going to interview you today. What is the process and how do they extract lutein and then zeaxanthin and mesozeaxanthin from the marigolds, where they grow marigolds? I believe in Mexico is a very popular place to grow marigolds, to make supplements, whether it's lutein, zeaxanthin, mesozeaxanthin, or the triple lutein, zeaxanthin, mesozeaxanthin.
Yeah, thank you. So basically, again, a very good question. So what we know is, and I've done experiments for every type of formulation, carotenoid formulation that's available, you know, every possible commercial industry that, you know, obviously they come to Waterford because this is what we do. So we've looked at everything that we can look at. And what we see with the carotenoids in terms of the extraction, it's really important, your question, because the quality of the formulation is uniquely important to the success that you're going to get in a research study, or in your case, in the clinic. So what happens? So basically, As you suggest, the marigold flower, the Cempasúchil, which is mass grown in Mexico because of the climate, okay? And they're basically hand-picked, the flowers from the marigold. And what they are, they're processed through a unique patented process, okay? Which allows you basically take the carotenoids out of the flower. And that's a process known as saponification. So it's basically like cooking the plant in a special way to purify the carotenoids and get rid of the fats that they were bound to in the plant. So in an ideal situation, you're cooking the marigold flowers and you end up with this purified carotenoid concentration. Now, typically in a marigold flower, you'll extract out lutein and zeaxanthin. And what happens as part of that process is something called isomerization happens, which is basically, Kerry, very simply, that the lutein molecule is converted into mesozeaxanthin as part of that natural extraction. We call this isomerization. And it's simply just that a double bond in the lutein moves one location. And we get this unique molecule called mesozeaxanthin. So the summary to the answer of your question is the formulations that we get to use in research and which are now commercially available in optometry, if they're a purified carotenoid blend, a triple carotenoid blend, as you allude to, this happens under a very strict health grade extraction process known as saponification. And then it's formulated in a way that you can purify and optimize the amount of these carotenoids from the plant, giving you high amounts of meso, high amounts of lutein, and zeaxanthin is there as well. As zeaxanthin is found in less concentrations in the marigold. You would have to go to other plants to secure zeaxanthin. Now you can from the marigold, but it's very, very difficult to do it at the concentrations that we're referring to.
Presbyopia, I have no idea how to say that.
Presbyopia? Presbyopia might be the ability to see Presbyterians.
There are people who are afraid of the press.
I have no idea what it is, honestly. Presbyopia.
A condition in which the eye loses its ability to focus.
Making it hard to see objects up close.
I've heard the bifocal, but not multifocal.
I have never heard of multifocal contact lenses, no.
Since I bought Safe For You, my dad makes me clean his boat.
Es natural y es un buen producto.
Every time I go back to school, my mom always makes sure that I have my Safe For You products. I bring extra, and my roommates certainly don't mind.
It's a good thing I had Safe For You to clean up after this little guy.
When my hands get dry, I like to wash them with Safe For You.
And most importantly, the reason why I buy Safe For You is because it's safe for me and you.